Alright, so let's go ahead and play this video.
Confused, wondering how the one is worth more than two. Teacher said, don't worry, it's easy. Here's what you got to do. Start from the decimal and you move to the left. You got the ones and tens, then the hundreds, thousands, 10,000s, and 100,000s, then finally we are at millions. You gotta know your place value. Don't you know what to do? You gotta know your place value. Multiply it correctly by content, you'll see you found a place value. I hate to say this, I have no clue. Don't get this at all. What happens when? What do I do? To the right of a decimal. Something the same way. Remember it starts with 10 you know. Spell it the same way. THS, good to go. Start with the decimal and you work to the right. You got tens, hundreds, and the thousands. Follow the same time so you know the rest. Just don't forget the THS. No, now I know my place value. Now I know what to do. Place value. I can solve anything. I can find its identity. Multiply it correctly. I can count 10 and say, I know my place value.
Awesome. So let's go back to this one spot. I just want to talk about it right here. So let's get our pen. So it says each place to the right is 10 times less than the previous place. We're going to be calling it 1/10. Okay? The reason why is because division and fractions are basically the same thing, and we're going to be learning about it. But yeah, very nice. I hope this video helps you learn about place value, and it's pretty catchy because it's about it's the song by Bruno Mars. Let's go ahead and move on. Alright, so we're going to have vocabulary words that I would like you to write the review words onto your left of the Cornell Notes format, and then the definition. Now, you don't have to write the definition word for word, okay? I would like it if you put it in your own words. So we're going to go ahead and look at estimate. Estimate is to find something close to the correct answer. So we're going to go ahead and do an example here. So let's say we have 34, and you want to estimate it to the nearest tens. So you would write 30, okay? And we know this because if it's less than 5, then you round down. If it's more than 5, you round up. And there's lots of sayings to help you figure that out. Factor is numbers that can be multiplied together to get another number. So for example, we could multiply the factors of 3 times 4, and that would give us 12. So here we have the factors 3 and the factor 4. Those are factors of 12. Multiply is pretty simple. Basically, when you are trying to find the answer of a multiplication problem. Place value, we just talked about it, so I'm not going to review it too much, but the value of a digit depends on its place in the value. So let's say we have 3, 3, 3. This is 30, right? This one is 3, and this one is 300. Okay, so they're all very different. Product is the answer to a multiplication. So I'm going to draw because this 12 is the answer to a multiplication problem. And then we have a quotient. So I'm going to do 10 divided by 2 equals, 5. 5 is our quotient. All right, so make sure you can pause this and write it down. We'll move on to the next one. All right, these are new vocabulary words we're going to be learning for chapter 1. So base, in an expression of 5 to the second power, 5 is the base. Okay, just as shown there. Distributive property, multiplying each addendum in a sum by a number, then you add the products. A lot of you have learned this, so I'm going to go ahead and just show it to you guys. But you had 6, right? My apologies. You're doing 6 times 34. Okay, so you could do the 6 over here to the left, on top, and 4 here. So 6 times 30 equals 180. 6 times 4 equals 24. You can add the two products, and it gives you your answer of 204, I believe. If I'm incorrect, please make sure to just add the correct number. To evaluate is to find the value of a numeric or algebraic expression. So to basically find the answer. So an expression does not have an equal sign. This is an expression. When you add the equal sign, it becomes, you must evaluate it. Okay? Then we have an exponent is, as you can see here, in 5 to the second power, 2 is the exponent. Basically, it tells us to multiply 5 2 times. So you would do 5 times 5, and that would give me 25. And that's for this one. Inverse operations, they're operations that undo each other. So the different operations we have are addition, subtraction, multiplication, and division. Okay? These undo each other, and these ones undo each other. Numeric expression, remember, it's just a phrase, mathematical phrase that does not have an equal sign. So important part, no equal sign. Orders of operations, basically, if you would please excuse my dear Aunt Sally, or PEMDAS. We're going to be talking more about this when we get into it, but you can definitely write it down now. A period is a group of 3 digits separated by columns. So, commas, my apologies. 5, 6, 8, and there's commas there. All right, let's get into the lesson. All right, so many of you have known these base 10 blocks. We have our cube, our long, our flat, and our large cube. And you can see what it represents by looking at the top here. Let me show you. Here, the number tells you what that represents. So our small cube represents 1. Our long cube represents, our long represents 10. Our flat represents 100, and our large cube represents 1,000. Now, something to remember is you could even, this could be our ones place, our tens place, our hundreds. I'm not going to be able to spell it out. And then that's a D. And then our thousands. Don't add TH because that's for decimals. Okay, so this is very important to know because I'll be using this information. All right, this is a place value chart that I have provided for you. It is laminated. Please take care of it. But basically here you can also see it goes all the way to the millions, but you can see everything, all the values. You can see that our number system is based by powers of 10. And we're going to be talking about patterns we see. All right, so let's go ahead and try this one together. We have the number 10. What is 10 times as much as 10? So basically, if we're going to go back here, let's say we have the number 10, 1, 0. What is 10 times as large? So you could add a 0, or multiply 10 times 10, and that's 10 times as large. I also like to use this value chart, and basically whenever it's asking you To multiply, you want to shift to the left. Okay, so there we have that. So our answer would be 100. Now, let's go back here. I'm going to go ahead and clear our, oops, where is it? There it is. Erase the ink on this side. So let's say we have 10. My apologies. We have 10 here. Now the question asked us, what is 1/10 of it? So this is basically the division part, but you're shifting to the right. So 1/10, would that be 1? Or take away a 0. Not all the time. Now let's do 70. 70 is very similar to the one that we had. Let me clear. Okay, we have 70. What is 10 times as much of 70? Good. It should be 700. How about what is 1/10 of 70? Good. It should be 7. I'm going to put it way down here so that way you can see it. 7. You don't have to add these zeros, but it's just important so that you can see the decimals. So we have 700 and we have 7. Let's go ahead and do 9,000. This one's a little bit different. 9,000. So we're going to put our 9 in the thousands place. What is 10 times as much? Good. Very nice. It should be 90,000. Now what is 1/10 as much? Good. It should be 900. Write that down. Make sure that you're writing this down in your workbook as well. Alright, let's go ahead and continue. Let's complete the sentences. We have 500 is 10 times as much. So we're going to go ahead and put our 5 in our hundreds and then add those zeros. What's 10 times as much? Very nice. Because basically all you're doing is multiplying by 10. You have 5,000. Very nice. Oh, my apologies. 5,000. Alright, let's do number 2. We have 20,000 is 1/10 of what? So let's write that down. 20,000. Add your comma to see it. Now 1/10. Remember shifting to the right now. So very nice, very nice. You can do that one. You have 2, 0, 0, 0. Again, you don't have to place this here, but you have the 2's in the thousands, so you have 2,000. Right. Let's go ahead and do this last one. We're at 900, and we want to know what is 1/10 of 900. Boom. You have 90. How about 600 is 10 times as much? Remember, 10 times, that's multiplication, so you're going to be shifting to the left. Let me erase this. We have now our 6 is in the thousands place, so we have 6,000. Alright, very nice. Let's go ahead and continue. Again, you're more than welcome to pause if you need time to write it down. So I'm going to go ahead and give you guys some time. Go ahead and pause this video to try to solve these problems on your own, and then go ahead and press play when you're ready to see the answers. You may use that place value chart to help you out. Okay. I'm going to go ahead and place the answers here. So the number is 10. We want 10 times as much. That should be 100. And then we want 1/10 of that. That would be 1. 3,000, we want 10 times as much, which is 30,000. And we want 1/10 of that of 3,000, which would be 300. We have 800, and that should be 8 times as much as 8,000. Remember, times shift to the left. 1/10 of 800 is 80. Then we have 50. So 10 times as much of 50 is 500. And then 1/10 of 50 is 5. Then we have 400 over here. 10 times of 400 is 4,000. And then 1/10 of 400 is 40. We have 90. Our number is 90. 10 times as much as 90 is 900. 1/10 of 90 is 9. We have the number is 6,000. We want 10 times as much of 6,000 is 60,000. 1/10 of 6,000 is 600. We want 10 times as much of 200, which is 2,000. And then we have 1/10 of 200 is 20. Awesome, very nice. Again, feel free to use this chart right here, okay? Use it. It is extremely helpful. All right, go ahead and pause and complete the sentences for these ones. It's very, very simple as well. So basically, you're just completing the sentence either 100 or 1,000. Okay? I'm going to go ahead and continue. 200 is blank times as much as 2. So 2 times a number, either 100 or 1,000, is 200. Good job, should be 100. 700,000 is blank times as much as 700. Now a little trick to see is I like to cross out these zeros. How many zeros do you have left? 3. So then it's going to be times 1,000. Now 50,000 is blank times as much as 500. I'll do my little trick again. How many zeros do I have? 2. So I will do times 100. 4,000 is blank times as much as 4. That one should be a simple one. Should be 1,000. 600 is blank times as much as 6. That should be 100. And our last one, 30,000. I'm sorry. Yes, 30,000 is blank times as much as 30. And we see there's 3 zeros. We have it times there. Good. Go ahead and explain how you can use place value patterns to describe how 50 and 5,000 compare. Basically, you can notice that you can multiply 50 times a number, any number, to get 5,000. Sorry, there's a specific number. 50 times a number gives me 5,000. So do my little trick. You can say 50 times 100 gives you 5,000. Mark and Robin use base 10 blocks to show that, my apologies, I can see 300 is 10 times as much as 3. Whose model makes sense? Whose model is nonsense? Explain your reasoning. Go ahead and take a look. So it's saying that 300 is 10 times as much as 3. So we can see here that Mark's model does not make sense. His model shows us 30. This is 30. Remember, this is our longs, our tens place. Okay? So he's actually showing something different. He's saying that 30 times 10 equals 300. Now the correct one here is Robin's, because she's showing 3, which is in our ones place. 3 is in the ones place. And you know that 3 times 100, which is what she's saying right here. 3 times 100 equals, I'm sorry, yeah, 3 times 100 equals 300. Explain how you would help Mark understand why he should have used small cubes instead of long ones. So basically how we can explain is that you can see that the longs are representations of tens place, whereas our small cubes, are represented of the ones place. All right. I hope you guys enjoyed our flipped classroom and took notes, and excited for Monday, which is when we will begin rotations. So thank you very much for watching.